Okay, so we're going to talk a little bit about the Fujita scale. And the Fujita scale was named and kind of invented by Dr. Theodore Fujita. Back in the 1970s, he was the one who kind of came out with the scale of ranking tornadoes by their wind speed. And this went into effect in 1971. And it stayed into effect until about 2007. And at that point, we kind of revamped, or other meteorologists kind of revamped, the Fujita scale, and now it is the enhanced Fujita scale. The difference between the two is the first Fujita scale just took into effect wind speeds, and that was it. The new enhanced Fujita scale takes into account how strong a building is and the damage that is caused. Because if a tornado comes through and let's say there's a mobile home sitting next to a brick house, well, which one's going to have the worst damage? Obviously, the mobile home is, because it's not as well built as the brick house. But it's going to take into account, this new rating scale is going to take into account the construction of those two. And so therefore, our ranking is probably going to be a little bit lower. Whereas in the past, it would just take the worst damage. Well, the mobile home has the worst damage, so then it might have gotten a little bit stronger rating. So with this, it again takes into accounting of the construction and how well built or not well built a particular structure happens to be that gets hit by a tornado. So kind of the difference between the two. So on your slide, you will see on the enhanced Fujita scale, we do rank them from 0 through 5, 5 being the worst. In theory, there could be an EF6, but honestly, at that point, the damage between an EF6 and an EF5 is virtually identical. And I have some examples of damage in the next couple of slides. And also, we just don't have any instruments that can withstand that. At that point, 200 plus mile an hour winds, anything's going to be destroyed. So in theory, yes, there could be a 6, but really, truly, the Fujita scale just stops at 5. So with an EF0, you've got wind speeds in between 65 and 85 miles an hour. And you kind of get a little bit of damage, maybe the gutters, you may get some, minor limbs down, that kind of a thing. When you get into EF1s, that's wind speeds in between 86 and 110 miles an hour. And you start to get a little bit more significant damage. You get some windows being broken, mobile homes being damaged, maybe some roof damage as well, and some other homes too. By the time we get into EF2, those are winds of 111 to 135 miles an hour. These are talking about roofs being completely torn off, well-constructed homes, foundations being altered as well, and mobile homes being completely destroyed. When we get into EF3, that's 136 to 165 miles an hour. This is extensive construction, extensive damage of well-constructed homes, severe damage as well. EF4, you've got winds of 166 to 200 miles an hour. This is well-constructed homes being completely leveled. And then when we get into EF5, that's 200 plus mile an hour winds. Pretty much everything is swept away. You may see a slab where a home used to be, but the home is no longer there whatsoever. So those are kind of the 5 different ratings. The weaker ones are your EF0, your EF1s, and also your zeros and your ones. Those actually account for the most tornadoes that we see. That accounts for 69% of the tornadoes that we see every year, those EF0s and those EF1s. And they account for only 5% of all tornado deaths. The EF2s and the EF3s, we will see about 29% of all of our tornadoes every year classified as those two. And then about 30%, or actually the vast majority of our tornadoes that cause the most deaths, are your violent tornadoes, your EF4s, your EF5s. Those account for about 70% of all deaths, but only about 2% of all tornadoes. So very, very few of our tornadoes actually reach that EF4 to EF5 ranking. So following along in kind of the PowerPoint, just a little picture of a tornado. The next slide is picture of a EF1, a little bit of siding damage on the house. You're going to have to call your insurance agent and have them come out and look at that. Then you get to EF2. So now you've got to get a little bit more significant damage. You've got the entire garage door blown in. You've got significant roof damage to this home. The next slide is an EF3. At this point, this home is completely destroyed. The roof has been completely ripped off. It looks like there's a car kind of sticking through the very front window right there as well. So a lot of damage on that one. EF4, your house is pretty much reduced to rubble. A lot of rubble is still there, but no discernible house whatsoever. But then when you get into EF5, you don't even have the rubble anymore. You just have that slab that just happens to be there. Now with one tornado in just one neighborhood, you can have all manner of damage. It doesn't have to be EF4 or EF3. This next slide shows some damage from a tornado that moved through. Houses on one side just saw EF0 damage, very, very little damage. But then some houses had EF3 damage, EF4, and then some were completely gone just a block away. So really and truly, it's very just luck. If one of these big monster tornadoes just happens to come through. Again, it's just kind of luck where that storm happens to go. And it's just not, the damage isn't confined just to the tornado itself. Those areas outside the tornado can also see significant damage just from the winds that are also being created as well. So quickly, just kind of run through some very strong tornadoes, very powerful tornadoes, and the rest of the PowerPoint slides. One of the longest ones was the Tri-State tornado. This is all the way back in 1925, and it did move through 3 states. It stayed very, very strong the entire time. Next slide is some damage from that. This next slide is a tornado that moved through Oklahoma, one of the most powerful ones. And then the next slides just all deal with the outbreak from 2011, April the 27th, 2011. Again, this was a day where we saw hundreds of tornadoes. In fact, 292 tornado reports over about a 48-hour period. The vast majority of those, a lot of those were in northern Mississippi and also northern Alabama. The next slide shows just how strong some of those tornadoes were. The state saw 3, I take that back, 3 EF5s, multiple EF4s, multiple EF3s. It was kind of an unprecedented day in the state of Alabama. And then the next slide is kind of a compilation of a lot of different radars and just the huge supercells that created some of those just very, very, very violent tornadoes. And then a picture of one of the tracks as it moved on through. So tornadoes, the most violent storms that we have on this earth. Thankfully, they are very, very short-lived, but they do produce the strongest winds that we see on the planet. So that has been a very quick look at tornadoes. We may kind of throw in a few more facts next week, but we'll also be moving on into hurricanes as well. Again, be sure to do a paper that is due next week. I want you to pick a state and the most powerful tornado that has come through that state and do a paper on that. How did it form? When did it form? The damage and kind of the result. What happened after that? You know, maybe the city or the state put in some new plans, new disaster management plans, ways to kind of get people to safety. See what the aftermath of that storm was, but also detail what happened within that storm. So you can pick any tornado, a powerful tornado, the most powerful tornado from any state that you want to pick. So again, about 2 to 3 pages. It doesn't have to be very long, but get that into me by next week. And then we will be moving on and talking about hurricanes. All right, thanks. Bye.